Hi everyone. Sorry I can't be with you today, but I thought that I would go ahead and video record the lesson that I was going to do so that you could watch it. And then if you had any questions, you can ask the substitute about it. After this, we're going to have the substitute describe to you the learning stations. I'll also describe them here, and you'll proceed with class as usual. So today we're actually starting a new mini unit on scatterplots. A scatterplot is a graph, and we're going to still be plotting ordered pairs that show relationships, which sounds an awful lot like functions, and they really do have a lot of similarities. Take a look at this screen and ask yourself for a minute, how are the graphs at the top the same as the graphs at the bottom? And how are they different from the graphs at the bottom? So maybe hit pause here before you listen to my explanation. Some of the things that are obviously different are the ones at the top are discrete, right? The dots are not connected with lines. They're just all over the place, and they really don't even form straight lines, hence the name scatter plots. They are scattered dots. But if we look at, for example, this graph and the one below it, they are very similar in the sense that they both are going up, right? We called the one down here a positive slope. And since these dots are also going generally in an upward direction, we also call them positive, but we use a special word. We use the word correlation. So we would say that the top one has a positive correlation and the bottom one has a positive slope. Now I can't call the top one a function because let's take a look. There are some dots that are stacked on top of each other, right? And we know if we do the vertical line test, it would fail. And so we wouldn't call this one a function, we call it a scatter plot. So let's erase those and talk about our second pairing. When I look at them both, I know that the bottom one, when I read from left to right, is going down. So we've been calling this a negative slope. Here, the dots are also generally going down. So we call this a negative correlation. We don't call it a slope. Again, we call it a correlation. Now the ones over here, this one we've always been calling a zero slope because it goes horizontally. But when I look up here, the dots are really just all over the place. So I can't call it a zero correlation. Instead, we just say this has no correlation. So there's lots of similarities between scatter plots and the slope of a function. We can have a positive correlation. That's our first graph. We can have a negative correlation. That's our second graph. Or we can have no correlation. That's our third graph. So what we're going to do now is we're going to look at a couple of slides. I'm going to read the short story that's on the slide, and then I'm going to explain what do I think this is, a positive correlation, a negative correlation, or no correlation at all. So here's the first story. By the way, true story. I do own a Dodge Durango, and I have had it for 12 years. So I've owned my Dodge Durango SUV for 12 years. When I bought it, the cost was $35,700. But now, 12 years later, it's worth $8,600. So I'm going to make a quick sketch. And I'm going to say years is on the x-axis. Cost is on the y-axis. And the reason I chose that is because years is independent. It's what's causing the cost to change. So at year 0, when I bought the car, it was expensive, right? It was $35,700. But in year 12, it's not that expensive anymore. It's about $8,600. What's going to happen as I connect those dots? It looks like a negative correlation. If it was a function, it would be a negative slope. Also, the way I can think about it is like this. As my years of owning the car goes up, the cost of my car goes down. Notice that these two arrows are pointing in opposite directions. When they point in opposite directions, that's noting a negative correlation. Let's take a look at our next story. Last week, also true, my daughter moved to Miami, Florida. She got a job down there, and she drove. After the first hour, she had traveled 58 miles. After 8 hours, she'd traveled 492 miles, and it took her 17 hours to get there. And all told, she traveled 923 miles. So let's make another little sketch. So we're going to put time on the x-axis because time is the independent variable. And we're going to put miles on the y-axis because that is our dependent variable. Miles depends on how much time she was driving. All right. So after hour number 1, she didn't drive very far. She'd only driven 58 miles. After hour 8, she had driven pretty far, right? She had driven 492 miles. And when it was all said and done, and she had driven for 17 hours, she had traveled 923 miles. So look what's happening here. The dots are going up, which notes a positive correlation. Another way to say it is as the time increased, the number of miles she drove increased. Notice that the arrows are going in exactly the same direction. That shows a positive correlation. All right, here's my last story. Let's say I walked down to the cafeteria and I talked to 125 students and I asked them 2 things. I said, how many siblings do you have? Like, how many brothers and sisters do you have? And then I said, hey, how many letters are in your last name? And I plotted that. Do the number of brothers and sisters you have anything at all to do with how many letters in your last name? Not at all. So if I graphed that, it would probably look like this. Dots crazily all over the place. And because they have no relationship at all to each other, I say they have no correlation. So here's a quick summary slide of scatter plots that we talked about. Positive correlation. As one variable goes up, so does the other one. So think about this. If the temperature goes up, 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 and it's just so hot, odds are ice cream sales will be high. Negative correlation, my arrows are opposite of each other, right? So when I'm first driving, I'm 16 years old, I'm pretty young. And odds are the number of car accidents I get into is going to be much higher than if I'm a little bit older. The number of car accidents I get into goes down. Opposite pointing arrows, negative correlation. No correlation, the 2 variables have nothing to do with each other. Let's take a look at this graph. So this is a graph about global warming. William was interested in global warming and climate change, and he noticed that the summers seem to have been pretty hot, but there's also been some really bad snowstorms in the winter as well. So he's not really sure what's going on with global warming. He did a little research. So look at this scatter plot that he created. Years going down the x-axis, the average temperature in Celsius on the y-axis. What type of correlation do you think this shows? To me, it looks like the dots are trending up. So I would say this has a positive correlation. I don't say it has a positive slope because I can't draw a straight line, but it generally has a positive correlation. So let's continue asking ourselves a couple of questions about this graph. If you had to explain William's findings in 1 sentence, what would you say? Well, I might say, as time keeps going on, it seems to me that the average global temperature is getting hotter. So let's make a prediction. Look at this first one. What do you predict the average temperature was in 1860? Well, the graph only starts at 1880. So 1860 must have been around here. So if I continue this positive correlation in the opposite direction, I might say that a good guess might be 13.4. But you know what? A good guess might be 13.5 or 13.2. When we do predictions about scatter plots, what I want you to know is that there are a lot of correct answers that will all be clustered together in the same location. Let's look at the next question. It says, what do you predict the average temperature will be in 2040? Wow, well, 2040 isn't until way out here. So I'm going to keep the dots going up into this positive correlation. And maybe my prediction will be 15 degrees Celsius, maybe 14.9 or 15.1. All of these would be great predictions because they're clustered together up here at the top of my graph. So let's stick with this particular global warming graph and let's ask our questions in reverse this time. This time we're going to look at 14.1, which is about right here. What do we predict the year was? Well, let's see. If I scooch across, I might say somewhere around here. It would have been 14.1. So maybe I would say 1962 or 1960 or 1964. But all of those guesses appropriately follow my positive correlation. Let's predict now, what was the year when the average temperature was 14.4? So now I'm going to look up here. I'm going to look across, 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 where I see a lot of dots and look down. So maybe I would guess the year 2002 or 2004 or 2001. All of these would be appropriate guesses because they are clustered together following my positive correlation. All right, so let's get out of global warming. Let's talk about this graph. On the x-axis, you'll see I have the hours playing a video game. And on the y-axis, the hours I've spent studying or doing my homework. What correlation do you think this one has? I see these dots going down. So I might say this has a negative correlation. What statement can I make about it? I might say that the more I play video games, the less time I have to do my homework. You see how the arrows are going in opposite directions? That's how I know it's a negative correlation. All right, let's make a prediction. I'm going to predict how many hours of playing video games if I spent 2.5 hours doing homework. All right, so here's my homework axis. Here's 2.5 hours. So let's look across. Here's where a lot of those dots are. Let me look down. So I might predict 5.5 hours playing video games if I spent 2.5 hours on homework. But maybe I could say 5.2 or 5.8. In that general area, all would be excellent predictions. So let's go in reverse. What do I predict will be the amount of hours doing my homework if I spent no time playing video games? All right, well, let's follow up, 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 up. I'm guessing the dots would be around here. So maybe I would predict 6 hours or 5.7 or 6.1, but they're all generally clustered in the same location. So let's take a look at our next slide. Our next slide is about the number of books in your backpack and how heavy your backpack is. What would you say the correlation is for this picture? These dots are generally going up. So I would say this has a positive correlation. Or the more books I have in my backpack, the more it's going to weigh. Look at how my arrows are both going in the same direction. That shows me positive correlation. Let's make a prediction. What would be the weight of my backpack if I was carrying 8 books? So we're going to go up, 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 and then maybe extend this positive correlation. And I might say 11 pounds, 10 and a half pounds, 11.2 pounds. In that general area would be an excellent prediction. All right, let's predict how many books would have been in the bag if it weighed 3 pounds. So here's 3 pounds. Here's where my scatter plot generally would be. And I know I can't have partial books, so maybe I would say 1 book or 2 books would be a good prediction. So I have something interesting. In my next slide, it's the same slide as this, except I just put a new dot on the graph. Is that new dot possible? Could I have 9 books in my backpack and it only weigh 3 pounds? Well, sure. What if I'm a kindergartner and I have those teeny tiny flip books or magazine type books? They don't weigh very much. So this is a valid piece of data, but it has a special name. Because it doesn't really follow my correlation, we call this an outlier. It lies outside where all of the other pieces of data are. It's kind of over here by itself. When we make predictions, we are going to absolutely ignore this outlier. But when we have to graph our scatter plot, we do have to put it on our graph. It's a valid piece of data. This kindergartner wants to be included in our scatter plot. But when we make predictions, we're going to ignore it and use where the data lies most tightly together. So let's look at one more type of outlier. So this graph shows how many times students were absent from their class on the x-axis and their final grade on the y-axis. So what general statement could I make? I might say that the more you're absent, the lower your final grade would be. Those arrows are going in opposite directions. So I would say this has a negative correlation. And I can see that the dots are going down, also showing me a negative correlation. But what can we say about this outlier? This person has not been absent very much, but their final grade is pretty low. So maybe this person was taking the wrong class. Maybe they were put in geometry honors and they were supposed to be in pre-algebra. Maybe they are just having a difficult time with the topic, even though they are at school all of the time. This is a valid piece of data. But if we were to make predictions about this, we would totally ignore it and we would make predictions based on all of these tightly put together dots on our scatter plot. So just to recap, I'm going to go back to one of the slides at the very beginning. This one. Scatter plots have a correlation. They can have a positive, a negative, or no correlation at all. And we can use scatter plots to make predictions. So what I'd like for you guys to do now, talk to the substitute if you have any questions about any of these slides. But if not, I'm going to ask you to do 4 different things. So our first learning station is a Desmos activity. It's called Dapper Cats. And what you'll see when you get there is you're actually going to be building cats with these cute bow ties. And as you build them, it's going to plot scatter plots along the way and ask you to make some predictions. The second Desmos activity is called Robots. It's very similar to Dapper Cats, except it's robots that are either tall or short. And you're going to be looking at the distance between their eyes. It's also going to build scatter plots for you and ask some questions. So just as a reminder, you go to student.desmos.com. I'm going to jot that up here, student.desmos.com. When you get there, you do Dapper Cats followed by Robots. Once you've finished those 2, if there is still time left in class, I want you to go to practice your fraction decimal percent conversion on a website called abcya.com. It's a game. You're going to be converting fractions, decimals, and percents, and then there's little pictures of birds, and you're going to place them in order from smallest to largest. That link can be found on today's class notes in Schoology. Remember, when you open up Schoology today, you're opening up Unit 2 scatterplots, not Unit 1's folder on functions. When you're done with the two Desmos activities and the fraction decimal percent, regardless, with 5 to 7 minutes remaining, there is a reflection as a Google Doc posted to Schoology. Please make sure you complete that before you leave fourth period today. Thanks so much for listening to this presentation. I will hopefully, fingers crossed, not be on jury duty for our next class. We can review any of this that you'd like. And what we're going to be doing is going on to drawing scatter plots as well. One last thing, I left for this substitute a new orange list of all of the lessons we're going to be doing on scatter plots, as well as some scratch paper that has graphs on it. Stick that in your green folder. If you don't know how to put it into the little tabs in the middle, I can help you do that when I get back, but it'll give you a nice idea of how short the unit is and when our test on this unit will be. Please email with any questions you have. After my jury duty is over today, I will check my email and get back to you. Have a great day, everyone.